Can everyone hear me okay? We'll get started in just a couple of minutes. As I think I mentioned, I am recording this just in case people decided that they wanted to head home early and watch that on their own time. That's totally fine. So we'll get started in about 3 minutes. In the meantime, I'll just silence my audio and my video, but as I said, I do have it recording.
Oh, that's not too bad. 60. Right. There another question, someone? Multiple choice, yeah.
Okay, everyone. Thanks again for accommodating this slightly unusual way of, well, I should say it's not completely unusual. It feels like a long time ago that I've done something online like this. It's always a little bit funny. Of course, during COVID, when I was teaching this course and many other courses online, it was just a regular part of the experience. And after being away from it for a while, it just seems a bit strange. But anyway, thanks again for accommodating this. And it, as I've said earlier, in case you missed it, it is being recorded. And I hopefully will have no trouble putting that up, fingers crossed, on the THER 205 Moodle page. But let's just get right into it. I don't think it will take us too long to kind of go through, I think, the most important pieces. And I thought maybe a good place to start was, in fact, to talk about the study guide, because that is really kind of what's going to direct this little review here. So the study guide, as you can see, I've got it highlighted there for last year. So hence 2024 is highlighted, meaning it will change a little bit. I just am still working on some final little details, but it doesn't change much. So you're looking at basically 95% of the exam as it looks here today. So last year was out of 68. I think it'll be out of similar to that. So call it up to 70, 65 to 70 marks. As usual, you'll have about 90 minutes to complete it. And you can see the breakdown. So lecture one, which is quite a review lecture actually from many of the other courses you've taken as well. So you can see there are 12 marks on that. And I'm going to pull up lecture one, we'll go through it. But it is on pain, assessment, tissue healing, like what are the timelines for chronic pain, and what are the pain afferents, the pain nerves, say, for example, the A delta and C fibers. So there are things like that. Also, things like just assessing pain, like visual analog scale. So 12 total questions. Also on there are things like pain chemicals, which we've talked about before, things like bradykinins, for example. So those study guide questions that we have gone through, and we will go through the study guide for light, are really an important part about where I get my questions from. So what I do is I go through again my PowerPoints, I pull questions out, and then I kind of make sure that the lecture review questions kind of match up pretty well. It's not perfect, of course. There are going to be a few that didn't show up for whatever reason on that, but they do show up on the exam, but they aren't meant to be tricky. Just sometimes it just works out like that. Okay, so that's lecture one. Lecture two, as we're going to see, is about the same, hot and cold. And I'll go through that. You can see 12 questions. Ultrasound and shockwave, you do, of course, see that it is the biggest area, which makes sense. It's a lot of technical information there. And then slotting into second position is light at 16 questions, and biofeedback, very, very few questions, maybe 3 up to 5. And again, those could change a little bit as I kind of finalize that exam, but looks like it'll be somewhere around there. So let's is that me drawing on there? Or somebody else drawing pictures? Anyway, let's go take a look at the review questions for lecture number 5. So I'm just going to stop sharing that for a second and bring up, let's see what I've got here. Yep, there they are. Okay, so I'm going to bring up the review questions from lecture 5. There we go. Share that. Okay, so hopefully you've all had a chance to go through these. And as you know, normally what I would do is I just kind of leave it up there for you, assuming you've had a week to look at these. And I know many of you have sent me questions checking in on the answers, which is great. But I'll go through these because of this unusual circumstance today. I'm just going to go through them one at a time. And hopefully they all make sense to you. If you don't, of course, if they don't, just make sure you do ask me. So the first question is, what is the name of a particle of light? Hope you remember that light is a wave and a particle, and that particle is known as a photon. When we looked at the range of visible light, it's measured in very small wavelengths, down to nanometers, and the visible light spectrum then is 400 to 800 nanometers. 400 sits on the blue side of things, all the way to the longer side, which is red at 800 nanometers. Which wavelength leads to quote unquote tanning, which we, of course, would be better described as the production of melanin by some of your skin cells. So that wavelength is UVB. It is the only frequency which actually is going to stimulate the production of melanin in your skin cells. Sounds the same, but a little bit different. And this is melatonin. So where does that get produced? As you probably know, that is produced in the pineal gland. Question number 5, what is an MED? So when we looked at light, we said there were a few applications that were therapeutic, things that physios and OTs do get involved in the use of course, laser being the most obvious, but also even ultraviolet. So we use ultraviolet to treat skin conditions, particularly psoriasis, which is a question for sure I've seen on the midterm exam. So the question of MED, which is also on the exam, I just looked at it. It does stand for minimal erythemal dosage, minimal erythemal dosage. And this just basically means what is the least amount of time that we can expose somebody's skin to an ultraviolet light to cause it to go red, essentially. And from that, then we can sort of make determinations about how much and how long and how close and things like that. But that's what MED means. I don't have a lot of questions on it, mainly because it's not as commonly used as the next modalities, which we're going to talk about right now. So the two types of lasers we use in tissue healing, well, the main one we use is the helium neon laser, which is called abbreviated HNE, and the other one is gallium arsenide. Now, which is GAAS. They basically are both infrared lasers. But another question, because I know people have given me this answer to this question too. Some people have said, what about the HILT, which is the high intensity laser? It's a great answer. So either of those answers, again, if we were to say the helium neon, HENE, gallium arsenide, which those are both class 3B lasers, so they're cold lasers. And then we introduced also the HILT laser. So any of those are technically true used in tissue healing. The only real difference there is that HILT laser is just a hot laser, so it does generate quite a bit of heat. But anyway, either of those would be fine. I think you would find on a multiple choice question, you would easily pick the answer out for that. Okay, so good. Let's move on to the color. So what color is the Heaney laser? And this one, we are really looking at this being actually kind of a greenish color. You can see where it fits into the electromagnetic spectrum. Remember, 400 to 800 nanometers, 400 blue, 800 red. The Heaney laser is actually kind of in a green color. It sits kind of in the middle. Whereas the one we're using is primarily more of a red color. It sits in more of the red color. It says, so this is question number 8. The laser we use in which part of the electromagnetic spectrum? It's called near infrared. Near infrared. Okay. All right. So related to lasers, and the laser we're using again is near infrared. So it's like a red color. What is one proposed benefit of it? One of the big things I'd come up with right away is it is really good for pain reduction. It's also good for increasing angiogenesis, so increasing circulation or blood vessels. And the other one is to increase collagen production as well. So quite good for all of those things. I only asked for one, but there are a few there. When we look at lasers, we talked about ultrasound. You may remember when we were talking about watts per centimeter squared. In lasers, it's actually joules. So just it's a different measurement of energy. Electromagnetic energy is measured in joules. Sound waves, mechanical is measured in watts. So this is joules per centimeter squared. Our laser is which classification? And that's class 3B, 3B laser. So this is a cold laser. The new classification of the HILT laser, the high intensity laser, and I just wanted to show this to you. I'm just going to quickly bring that up because it's just, it is a new part of my lecture, and I wanted to make sure you would know where to find that. Oops, daisy, there we go. So the HILT laser, I didn't talk about it till much later on, and it comes in right here, HILT. So one of the things that's different about this one, you can see here is a class 4 laser, class 4. So that's HILT. Okay. So let's continue on with these questions. The photons in our laser are absorbed in this organelle. So in order for the laser to have any effect, you have to absorb photons, and they're absorbed in the mitochondria. These proteins are produced in response to significant heat, and they're known as chaperone proteins. We've seen this question come up in other courses as well. And these are heat shock proteins. In fact, we talked about this in lecture 2 when we talked about heat and cold. They're called heat shock proteins, or HSP. Saunas are actually a therapeutic form of heat as well, and they can generate and deliver heat, radiating heat quite deeply in some cases. And the most saunas, they're actually going to be in the far infrared part of the electromagnetic spectrum. So far infrared. Switching to a very, very low part of the spectrum, which is called ELF, that's 3 to 300 hertz. So this is very low frequency. 3 to 300 hertz, that's for number 16. Number 17, for any electromagnetic device, whether it's laser or PEMF or ultraviolet, to have an effect, what must be absorbed? Of course, everyone probably guessed this is the photon. You have to absorb the photon. And then it has the ability to energize the subatomic particle, or the atom, really. Which part of the EM spectrum is the dividing line between ionizing and non-ionizing radiation? And again, you may remember when I put that kind of image up to look at the wavelengths. The dividing line, remember that the rainbow is a very narrow part of that spectrum, only 400 to 800 nanometers. Well, if you just go a little bit higher frequency or shorter wavelength, you get to the ultraviolets. Now, just the ultraviolets have 3 parts to them. They have A, B, and C. B, as we know, is going to cause increased melanin in your skin, but it's actually the dividing line is C. It's ultraviolet C. From C and beyond, including C, it is ionizing. So there's enough energy in the photons to cause actual free radical production, to cause damage to DNA, essentially. So that's one of the challenges when you get exposed to ultraviolet C. Fortunately, most of it does get, again, kind of taken out by our environment. Okay, so that's the questions for 1 through 18 on light, and we've obviously done the other ones, but what I'll do now, I'm just going to stop my share here for a second, and I'm just going to share a different slide. I'm going to bring up my lectures on lecture number 1, intro. I'm just going to pull them up now so I can easily share them, and then we'll look at number 2, which is heat and cold. Bring that one up, and we'll do, of course, ultrasound and shockwave. Got that one, and then we're doing biofeedback as well. And of course, we've already got light up there. Okay, so the reason, again, I'm doing the review like this is to, it gives me another chance to sort of highlight the areas that I, really now very familiar with in terms of your midterm exam, which now, again, is 65 to 70 marks. So let's take a look at that. So I'm going to share screen here again, and we're going to pull up a couple of those PowerPoints. There's number 1. So let's share that. Okay, I'm just going to move this out of my way. Good. Okay, so let's just jump right in. And again, one thing I think it's important to point out is that these standards, which I put up I put them up in every lecture because it's just so important to remind ourselves like where the regulations and guidelines come from. Yes, it does come from this new College of Healthcare Professionals of BC. I have decided just to put no questions on this. I've cut them out mainly because I think it's just been done, I thought, quite well in other courses, particularly THER 130. I even mentioned again THER 230, so I'm just going to not have them in this exam. But they are all there, and just in case you wondered, they do have these documents, and I think I won't say anything more than that. Then it just sort of sets up, a little bit of an intro. As you know, I don't really see any questions in these first few slides. It's just setting the stage, why we're using it. Again, it's mainly gating. I don't have anything on OT as far as the modalities go because they kind of all could be used for OT or PT. I didn't even put anything on paraffin, so just to let you know that. As far as the research goes, I've also felt that was kind of a good bit of background information, but stuff that we've covered before. That's evidence-based practice, so I didn't put any questions on evidence-based practice, including that slide there. Same thing with CIP. I thought it was just kind of an interesting thing when you talk about pain to note that there are people who actually can't feel it. Same thing with culture and pain. So far, really nothing as far as questions go. They really begin here. It's the idea of a red flag. Sort of basically saying there are certain things when it comes to pain that we cannot treat. And it's always good to remind yourself of what those main red flags are, such as cardiovascular pain, and the other one, which is night pain with unexplained weight loss. Those are 2 red flags that when I hear them, I send them immediately back to their physician or in many cases to the emergency room. Then, of course, it's review, right? We talk about pain receptors, and I think everyone gets the idea. I am going to ask the question on the pain chemicals again, so you can see them here. Remember, it's multiple choice, so I don't think you'll have any difficulty pulling the question out of that. The definition of acute pain versus chronic pain, I do have that. For example, what is bolded, how long chronic pain, when it starts, which is 3 months. Okay, so there are some questions there. This is not a bad question. The mechanisms, I think you'd have no trouble. I've asked it before in THER 130, but it certainly is a fair question. Treatments must be biopsychosocial. I've covered that fairly well in THER 230, but I think it's fair that it could show up again. Chronic pain is such a hot topic. So just to remind you again that all treatments for chronic pain have to include biology, psychology, and some social aspect to them. Nothing really here. It's just sort of a bit of a review of how, basically we can treat chronic pain quite well, but where does the changes take place? And that, of course, is in the homunculus. Hopefully we can actually rewire the brain. Referred pain, I don't really have any specific questions on this here. You should just know, of course, that something central is more likely to refer away. Pain scales, yes. I do have a question on pain scales, particularly things like the visual analog scale, the pain scale, like this 10 centimeter line, for example. I do have that because it's used so commonly. McGill pain questionnaire, I ask it a lot. It's possible, that you should know the three categories of the McGill pain questionnaire. And it's just a more detailed way of getting to the assessment or evaluation of somebody's pain. There are no questions on these quality of life scales or anything like that, just to give you an example. And then, as far as this slide here, pain receptors, the A delta and C fibers, as it relates to gating of pain, yeah, I have a few questions on that. They're review, they shouldn't cause you any difficulties. So here we are again. What is the kind of pain? I usually ask that one. The longer kind of burning sensation is C fibers. That's an unmyelinated. Dorsal root ganglion, not much there, but I definitely am going to ask, where does the gait actually happen? And just to remind you, that's in the substantia gelatinosa. Yeah, I think that really covers the basic parts. So know the parts of the gait control theory, those A delta, C, A beta, which is the proprioceptive one. Where does it mix? Substantia gelatinosa, and then it refers up to the thalamus and eventually to the somatosensory cortex. Descending modulation is a sort of a new part of the gait control theory of pain. So what I've just described is the gait control theory, and descending modulation just adds some endogenous opiates into the substantia gelatinosa. So not only do we have gating the old way we know for the A beta, but what we now know is that the brain actually will send down chemicals and release them right into the substantia gelatinosa. And these are just endogenous opiates, and they are excellent painkillers. I don't have it as such in the exam, like define opiate versus opioid, but I call them endogenous opiates. Here's some examples of them, by the way, in case you aren't aware. Dopamine is actually an endogenous opiate, excellent painkiller. So is serotonin, of course. Stimulate A beta. I don't think there's anything more I can talk about there. Yes, all of those would break this pain spasm cycle. Tissue healing and repair. Yes, there are a couple questions on that. They are totally review. So how long does an inflammatory stage last? 48 to 72 hours. How long does proliferation, what is the main thing happening at proliferation? And of course, just to remind you, that is the laying down of collagen. And then, of course, it's remodeling, which goes on for a long period of time, potentially up to a year or two. Delays in wound healing, it's always a decent question. Why do things not heal well? That's not a bad question. Nothing here, nothing on that slide. Oh, the knot. Yeah, I might have a question on that. What is it? This knot in the upper trapezius, it is the subtrapezial plexus. It's more of a lab thing, but technically it show up. I do have a question on the trigger point, however, so just note that I will ask sort of the definition of a trigger point. Treatment for it is kind of lab more likely. So when we get into these receptors, I don't really see any real questions there. Nothing here. Tender points versus trigger points. I think I'm more focused on the trigger point. Tender points more like fibromyalgia. Cupping. Yeah, I have a couple questions on cupping, not many. I think I have one, possibly two at most. So know the difference between the kind of cupping that's used in physiotherapy, which is dry cupping, versus wet cupping, which we don't do. I think that's most of the questions. As far as fascial rolling goes, not really that I can recall that being a significant question. Okay, so remember there are 12 questions from that lecture. So let's put that down and let's bring up the next one, which is lecture number 2 on hot and cold. Oops, daisy. Share that one. There we go. Okay, so hot and cold. Let's get into that. Of course, as everyone knows, it starts off just about all my lectures with Hippocrates. So there he is. I don't actually think I ever put him on any exam question, but yeah, background information. Yes, I do have a question as I've bolded there. Where do temperature signals from A beta go to? And they go to the hypothalamus. That's where they those temperature sensors get regulated, or sorry, get sent to. Shivering or sweating, I don't. Well, other than the fact that it's the hypothalamus that then sends that signal to the appropriate parts of our physiology, whether it be our muscles or blood vessels. So yes, this slide here, it definitely is a question. So know the difference between conduction, convection, radiation, conversion, or evaporation. It's a question. I just looked at it. I know it's on there. Multiple choice again. Insulator versus conductor. I don't think I do have a question on that. It doesn't sound familiar to me. Gate control, we've covered it already. Difference between therapeutic heat of superficial and deep. Yes, it is for sure a question. Mild heating, less than 40. Yep. And vigorous is 40 to 45. That is definitely a question. Reflex heating is also on there. I just looked at it. So know what reflex heating is. Gating, I think we've talked enough about that. Cold versus warm, nothing really there. Right. I do have a question on how does heat or cold reduce muscle spasm? I think it's something to do with that. Anyway, your answer sits in here. Basically, it does increase the firing of GTOs. So through that, it becomes inhibitory. I don't see too much there. Hydrocollator pack temperatures is a question for sure. 71 to 79. Contraindications, yes. Contraindications of heat and or cold are definitely on there for sure. This prior to heat is more of a lab thing, and we've kind of already done that enough. Maintenance, I don't think I have any questions on maintenance. Paraffin done. Fluidotherapy. Don't believe I have a question on fluidotherapy. I'm just going to make a note to myself. I just want to make sure, but I don't think it's on there. I think I just left that. Diathermy, yeah, I have a question on diathermy. Basically, it is a deep heating agent, and there are essentially two types. The two methods are induction versus capacitance, and I know that showed up on the review questions I had for heat as well. Just want to double check that one as well, making sure that is on there. Saunas, I think we've talked a lot about that, so I don't see any other questions here. The Finnish study, interesting, but not really examinable. Heat shock proteins, everyone knows I'm going to ask that. You know, it's a very basic question, just what are they? And I like the question of when do they get produced, and that's above 42 degrees. So just note that one. Cryotherapy, same thing. We want to know that I'm going to ask the question about pain reduction, which is just gating, the muscle spasm thing. So both heat and ice work the same way to stimulate GTOs. So that's a fair question. C-band, I don't, do I have that? I can't remember. I don't think so. I'll double check that one. I'm just writing that note down. It's possible. Just what does the acronym stand for? Nothing on cryocuff. C-band again. Cold precautions. Yes, this is definitely a question. So the hypersensitive, the cold precautions, and particularly those again who have cold sensitivity. So know that cold sensitivities is a contraindication. And I always find that word really funny, you know, because it doesn't sound like it's that serious. It's like, oh, you're just sensitive, but it actually is kind of serious, and that is definitely a question. Is what are the cold sensitivities or contraindications to ice? Wim Hof, I don't have anything on Wim Hof. That's just trivial. Nothing there. Heat versus cold. Yeah, I do have a question on heat versus cold. I think you'd find it very straightforward and easy. You know, what you like something to the effect of which of the following are indications or uses for heat? Yeah, and I think you would know that you wouldn't put heat on something that is hot, red, and swollen. Basically, if you know that, you kind of got it figured out. Okay, good. So that was lecture number 2. Again, they're about 12-ish questions, I believe, on there. So let's go now to look at lecture number 3, which is kind of the biggie where more of the questions come from. That's biofeedback. Where did you go? Oh, there we are. Okay. Ultrasound and shockwave. So, yep, definitely a few questions on here. So let's go find them. So, nothing here to begin with. It's a little bit of background, trivial information. Lithotripsy, I can't remember. I'm just going to write a note to myself if that is a question, but it just is the origin essentially of ultrasound. They found by turning it up really high that you can destroy that. So I suppose it's a word you should know. Audible range, I do like ranges, as everyone knows. I like ranges and scales. And that's not a bad question. 30 to 20 kilohertz, sorry, 30 to 20,000 kilohertz is the range of human hearing. And as we know, ours are in megahertz, which are millions of hertz. So you cannot hear our ultrasound. And in fact, most things would not be able to hear our ultrasound, even dogs. Okay, so let's move on. So that's a possible question. The difference between our ultrasound and diagnostic isn't a question. However, that thing on the very bottom, which you should know the range of our therapeutic ultrasound, I have in there 1 to 3 megahertz, just that's what we have on our machines. It actually does start technically at 0.75. So just note that could show up on the exam. The range of therapeutic ultrasound is 0.75 megahertz up to 3 megahertz. Okay. Compression and rarefaction. Yeah. So I am going to ask a question on that for sure. So you should know that rarefaction is the negative part of the wave. Yeah, I'm going to ask that. Okay, let's see. The next one we're looking at is energy transfers, compression, rarefaction. That's just kind of the same. Oh, the two modes of waves, longitudinal and shear waves, is for sure on there. So just note that. Inverse relationship, yes, between absorption and penetration. That's a definite question for sure. More collagen equals more absorption. I don't know if I have that specifically as a question, but it's not bad. I'll double check that by writing that down. Collagen, more absorption. It's just, it is more density. So the waves are not going to pass through it so easily to get absorbed by it. More absorption. Okay. Right. Reflection and refraction. Yeah, I know this kind of gets a little bit, I don't know, overly complicated, I think, than it needs to be. But just to remind you, whether it's light or sound waves, if a wave hits something and more or less bounces back at a what we usually call a 90-degree angle, or even straight back, we'll usually call that reflection. Versus refraction is that some of the sound waves get bent. They get bent because some of it gets absorbed. So if we want to simplify it, we could say whether it's light or sound waves, reflection is a bounce back. Refraction is a bending of the wave, whether that's a sound wave or a light wave, just a bending of the wave. And there are various reasons for that, but a lot of it has to do with just how much gets absorbed. So reflection, bounce back. Refraction is some kind of bending of the wave. Stationary wave, I do have a question on that for sure. And basically, the stationary wave is saying when waves are summated together, brought together, added together, they build up in their intensity. And that can happen for a variety of reasons, but the most common reason in ultrasound is that they are basically, if you hold the ultrasound head, don't move it, you can create a standing wave or stationary wave, same thing. Frequency equals depth. I put it in red. It is a question for sure. I'm going to ask that. What is the setting which determines depth of penetration? And yes, it is frequency. You can see the settings are there. So frequency equals depth. Higher frequency is more superficial. You should know that for sure. Power measured in watts, as you know, watts per centimeter squared specifically. And I do have a question too on what are the settings that would be most likely for an acute soft tissue injury using ultrasound. So remember, frequency has nothing to really do with that. That's to do with the intensity, so a very low intensity, and also the whether the duty cycle, right? The duty cycle, the on-off time. Those are the two things that determine whether it's acute or chronic, essentially. And there's duty cycle there. So I have a question as it relates to duty cycle and acute stages of healing. Treatment time, I don't think I specifically do, although again, it does fit into the more acute it is, the less time you're going to have it on. Chronic, you're going to put it on a little bit longer, generally speaking. This is just a clinical case study. I don't have this clinical case study on the exam. Crystal, I do have a question on it. It is the crystal that vibrates. So if you don't know that, please do know that now. That's underneath the transducer head. I don't believe I have any questions on spatial peak intensity. All that means is just that that's the maximum amount of power that could be emitted from that sound head. I don't know. It's like you can't really see it anyway. It's kind of designed by the manufacturer. This thing of 2 times the ultrasound head is a good one to know, that you can't really radiate anything bigger than 2 times the ultrasound head. Water immersion techniques, I don't think I have anything on that. Thermal, yes, I do have something on cavitation. So know that it is cavitation that raises the tissue temperature, and that's the contraction and expansion of gas bubbles, essentially. Unstable cavitation, we know that that's going to occur when we get into the deeper tissues, because there's just a lot more fluid and water in there, so it has more likely to cause this rupture of gas bubbles. We'll also see that in shockwave, we actually want and will create, in fact, unstable cavitation, but not in ultrasound. We want stable. There are the non-thermal effects. As I said, it's definitely a question, the mechanical vibration or acoustic streaming, those 2 non-thermal effects. Just jotting that as a note to make sure. But that's a good question for sure. The 2 non-thermal effects. I like to ask that one on the lab exam as a knowledge question. Non-thermal effects, also a good question. So when those mechanical vibration, acoustic streaming effects happen, what exactly is happening? And you can see some of these things here. Increased angiogenesis, protein synthesis, i.e. collagen, capillary density, etc. Okay. Jowl, maybe as it relates to, I don't even know if I actually have that as a question, but it's possible. I don't know how I would even ask it, but I think it is. It could be a question, but it's not big. Phonophoresis, there is nothing there. That hence FYI. Precautions, contraindications. I always like them, so there's a fairly good question for sure in there. Immersion technique is said, not anything there. Research, demonstration. We're getting into lab stuff now. Okay, then shockwave. So shockwave, yep, I'm going to ask the question of which one is the most common one, which is the one we use, which is called radial shockwave. We're creating unstable cavitation, just to remind you. And I have a question about like the shape of the wave. And when I say shape, this is what I mean. I mean like, the ultrasound wave goes like this, but that shock wave is a very strong positive wave followed by these little aftershocks. Incidentally, that big shock wave and these little aftershocks, the aftershocks are even thought to be created by popping of gas bubbles, unstable cavitation. Indications, mainly it's chronic, so you can see everything there sort of fits into that category potentially. Depth of penetration, it's kind of like ultrasound. It goes about the same, 3 up to 3, maybe 5 centimeters. Contraindications, as always, they're good questions. Biological effects here, we can really say that the unstable cavitation is producing many things. One of the things that worth noting is these chemicals it produces do increase vasodilation. They increase blood flow, And they also are going to cause quite a significant inflammatory reaction, which may seem weird, but we're trying to drive healing back to kind of reset or restart healing. I would not memorize all of these things here, like all of these VEGF, NOS, PCNA. I wouldn't bother doing that. That doesn't seem like a good use of your time. This is what ours looks like. Video parameters. That's just the settings we use. Nothing on that. I do have a question on the settings of shockwave, and please note that it is in millijoules. Bar is just a comparable setting, but bar is, I believe, British and millijoules is American. I might have that backwards, but we'll just call it millijoules. That's the setting we've been using on our machine. Procedure is a lab thing. Difference is kind of a lab thing. Oh yeah, this thing about a crystal. There's no crystal in the radial. That's a decent question. Well, that's a major difference. No crystal in the shockwave. Okay. All right, that wraps up that one. Then we have a little one on the biofeedback, which I'll just take a quick look at. Remember, there are only three. So, like about 20 questions or so on that section we just did. On biofeedback, as we're going to see, there are very few. There's just three little questions. So let's take a look at where those show up right now. Okay, so biofeedback. Here we go. Yeah, so background info here. Migraines, biofeedback. So I have a question on uptraining. Like, what is uptraining? That's just increasing the number of motor units. So that's a question for sure. The MyoTrack surface EMG. Not really. It's more of a lab thing. I don't really have too much here. Down training, I would know the difference between up training and down training. Up training, you're trying to activate more motor units. Down training, you're trying to turn them off. Also know a couple of examples of commonly up-trained muscles versus commonly down-trained muscles. And I do have a slide, as you probably know, on that. Like that. So that's a decent question. Which muscles are commonly up-trained and commonly down-trained, which of course is tense muscles like masseter, temporalis, upper trapezius. Temperature, no. So, galvanic skin response, just know that that's about measuring skin resistance, and that's about sweating essentially of your hands. The more stressed you are, the more sweat you will produce in your hands. So just know what GSR stands for, galvanic skin response. I don't think I have anything on HRV or ANS. I'm just double checking that. Okay, polygraph, no, it's not that. Okay, all right, and then that leaves us just so again, only pardon me, three questions on that, and then we have the final one, which is light, which is the second biggest area. So let me just share that for you. Okay, so go back to the beginning. Since we just did the review questions, it should be pretty obvious, I think, where the questions are. Visible light spectrum, you know I'm going to ask that. That's a fair question. The spectrum itself, not really, other than the numbers, right? So I'm going to ask the question on the visible light spectrum, and there are a few other specific questions related to different parts of it, which I'll bring up in just a second here. The photon is the surfer. I'm just going to excuse myself for 1 sec. I realize my I didn't plug my computer in, so it's going to die. Just give me 1 second.
That little chestnut. No one else is on camera.
Nothing. I'm like,
Okay. 'Cause- 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 'cause-
Okay, that should be better. So yeah, as mentioned, the particle of light, of course, is the photon. I think you know that's going to be a question for sure. So let's see what else we've got here. Reflection, refraction, absorption, these are all the same terms as we've discussed, and everyone knows we need absorption. Again, you can see here with reflection, it's usually kind of, most of it's just bouncing off, often at a 90-degree angle, or sometimes even straight back, depending on the situation. But it's just nothing gets absorbed. Photoelectric theory, do I have anything on that? Don't believe I have anything on that. Cares about it. Photons. Yeah. Okay. Nothing here that I can see. Nothing there. Nothing there specifically. Melatonin, I'm going to ask that question for sure. Pineal gland, definitely a question. Where is melatonin produced, as that was already on the review question. I do have a question on seasonal affective disorder. So just know that I am basically just definition, like what is it? Or what does SAD stand for? Spectrum. Right. So I do have a question on, what is the wavelength that gets absorbed to cause the production of melanin in your skin? That's UVB. That again, that was already gone over. The treatment of psoriasis with ultraviolet is a question as well. I don't have the actual numbers, so don't feel like you have to memorize, UVA is 320 to 400. Don't do that. That wouldn't be useful. Incident and dosage, nothing here. MED, as you know, I'm going to ask you what that is. It's just the time it takes to cause some redness to happen in your skin with ultraviolet light. Tanning beds, I don't have anything on tanning beds. Infrared radiation, not really, other than the sauna question, and of course our lasers. So let's get into that. Laser, the acronym is a good thing to know. I think I have that. I'm pretty sure I have that. So anyway, if you don't, it's light amplification by stimulated emission. Characteristics of a laser is a good one too. Characteristics of laser. I like that one. So it is monochromatic, meaning one color. Coherent, they don't diverge, they go straight, all traveling parallel. So that's kind of their two major characteristics. I'm going to ask a question of, the class of lasers, because we use class 3B, so we should know that. And the two types are helium neon and gallium arsenide. Depth of penetration, not really. Contraindications, as always, I always ask that. What they do, that was on the review question. So yep, that's a question for sure. I'm the mitochondria question for sure. The high intensity, I don't have a lot of questions on this because it's not clinically very commonly used yet. The only question I could see possibly is that it's class 4, which means it's a heating laser. I don't think I had any questions about contraindications again, or indications, because it just isn't that commonly used yet. It's getting more common though. Infrared saunas, yes, I have a question on that. I think you know that. Basically, where the saunas are on the spectrum, and that's far infrared. As far as the heat shock proteins, yes, of course, that's a question. Nothing too major, right? Just what are they? And I do have a question on the extremely low frequency range, which is 3 to 300 hertz. So know that number, 3 to 300 hertz, extremely low frequency. We actually can use it therapeutically. I used to have a question on Schumann resonances. I've cut it out. It's not there anymore. So don't worry about that slide. The only thing I suppose worth knowing is the modality we use for ELF is the PEMF MAT, pulsed electromagnetic field MAT. Alpha waves, I also cut this question out. I used to have it on there, but I've cut it out. So don't worry too much about the brainwaves or any of these slides on cellular effects, other than to know that the modality we can use, that's ELF, is PEMF. Extremely low frequency, we can use a modality called pulsed electromagnetic fields. And that would be plenty. And that's what it looks like there. Contraindications, I don't think I did that on there. Okay, so that, I'm just going to stop sharing that for a second. So hopefully that was helpful for you. I feel like, I've hopefully directed you to where the questions are on those 5 lectures, and the study guide, which I'll put together officially no later than tomorrow. I'm working on it today. Again, it's probably going to be out of 65 to 70. If I go through it and there's something that I didn't talk about today that I thought you should know, I'll definitely let you know that. Other than that, though, I hope you feel like you're fairly comfortable with the exam. I don't think there are any tricks. I think if you felt you've gone through those review questions and you noticed where I was picking the questions from, that I don't think it should be too bad. I think it should be just fine. If between now and next week, which is when the exam is next Monday, you do have any questions, make sure you do let me know. But otherwise, I probably will just ask if anybody has any questions right now. I'm happy to answer them for you. Or if you want to email me, then you can certainly do that as well. Any questions at this point in time? Okay, well, my pleasure. So hearing none, like I say, I'll just leave it to you to send me email, of course, but I do plan on being in class tomorrow. I'm feeling quite a bit better. So this is unprecedented for me. This is like the first time in 5 years I've actually missed a class due to sickness. Pretty weird. But everyone else in my life is sick, so I guess I was bound to get it eventually. I was way too arrogant about my immune system. That's what happens. But anyway, I should be there tomorrow. And if I'm feeling just a little bit unsure, I will wear a mask, but I am planning on being there tomorrow. We'll do a review, and we'll talk more about the lab exam, of course, tomorrow, like what that format looks like. I'll give a little more thought to that today, but basically it's going to be, you're going to pull either an ultrasound or a shock wave or a laser. It's one of those 3. And it's just, I'm going to give you the settings, you demonstrate your technique, and away you go. And it's kind of the same thing as before, like 20 minutes total, 10 minutes each, review question, same format as I always do. That's the plan. Okay, I'll leave it at that. And thanks so much, everyone. If I don't hear from you, I will see you tomorrow. See you, everyone.
Thanks, Brad. Thank you.
Bye-bye.
Thanks, Brad.